Hi, Damien here from Millie Mechanics. Today I'm going to teach you some level design tricks to guide your players intuitively without forcing them to read a single text tutorial. We'll be solving these design problems together because problem solving to me is the most important skill you can learn in Millie Wonderland. This is a three-part series. Today we're building a code wheel system and the logic behind it. And in part two, we'll build a dynamic lantern mechanic. And in part three, we'll put it all together into a finished map. The core puzzle relies on discovering a code sequence. A good example of a similar puzzle in Genshin, you might recognize these puzzles in Natlan, where the quantity of buckets hint at the order you light the torches. We're going to do something similar. I've scattered these collapsed wheels around the map. The number of wheels in the pile gives you the order. The elemental badge leaning against it gives you the code for that position. By combining the environmental clues with the first wheel / second wheel tab UIs, the player will intuitively learn that there are 4 elements to pick from and a specific sequence to follow. Here's the flow of the level. You are stuck in a cave in point 1 with the first code wheel stack, and behind you the scattered code wheels hinting at the answer. After solving that code, you step out into a larger area near point 2 with a deadly gap to your left. Across the gap is what appears to be the finish area, and right in front of you at the ledge of the gap are more code wheels stacked high and a stone podium. But no hints, you're stuck. So you go to the only other place you can, which is further in and to the right off a ledge in point 3. Down below, a glowing lantern with a field around it is seen. As you observe it on the way down, you notice an elevator platform appearing when it touches the lantern's glow and disappearing when it leaves the glow. So you fly down, and as you get close to the lantern, you can grab it, and you eventually ride the elevator back up as it is the only way back to the top. And suddenly, hidden bridges appear in the light as you reach the peak of the elevator, giving you a way out. You carry the lantern back to the gap, noticing as you approach the once inactive stone podium, it opens up, and you can then place the lantern on the podium, and it projects a beam revealing a network of invisible bridges across the gap in various states of high and low. Now use the code wheels again, but this time we subvert expectations because there's no hidden code defined. You solve the puzzle by watching the physical bridges move as you spin the wheels instead of finding a generic hidden code. You are directly seeing the invisible puzzle mechanisms and moving them through this unique lantern mechanic. So let's dive into the logic of this and set it up. To make this work, we need a code wheel system, a puzzle manager, and a lantern with collision detection, as well as a laser bridge design. So let's start with the wheels. So we'll have 4 elements around the wheel, and the wheel will spin endlessly in both directions. So to code this, we will use Modulo 4. Modulo just means a set of numbers that loops infinitely. For us, that's 0, 1, 2, and 3. If you're at 0 and subtract 1, you loop backwards to 3. And if you're at 3 and you add 1, you loop forward to 0. It's like a clock face, but with only 4 numbers. Here's why this is so powerful. In our base prefab, Hydro always starts at the front. So Hydro is 0, that makes Pyro 1, Electro 2, and Geo 3. But we don't want Hydro to always be the answer. We want to be able to set a secret code. To do this, we just shift where the 0 is hiding by changing the current POS, or current position I'll call it, variable to the elemental badge where we want the 0 to be at. For example, if we want Pyro to be the answer, we change the wheel's current POS variable to 1. We just target 0 has moved to Pyro. So by just moving where 0 is, it makes checking the puzzle infinitely easier later. We don't have to check a complex sequence of codes. We just use a loop to check if every wheel's math value or current position value currently equals 0. Now the player has to get the front of the wheel back to 0. They can spin counterclockwise once, so you subtract 1. So 1 minus 1 is 0, and Pyro's at the front. Or you can spin clockwise 3 times, which adds 3 to the number. So 1 plus 3 equals 4, which should wrap around to 0 with modulus or modulo. And now Pyro's back at the front, solved. So you can go clockwise or counterclockwise. Whichever way you go is just one is going to be the longer way. Next up, the lantern. We teach the player what this does purely through gameplay. So it just has like a sphere, a collider wrapped around lantern, and with some SFX that matches the boundary of that. And whenever an invisible bridge enters that collider, we turn its model on. When the collider leaves, or when the lantern leaves that bridge's collider, the model turns off. And you can see by my cylinder drawing here, It represents the radius of the lantern, and anything inside is visible and anything outside vanishes. This is where it all comes together. The light bridges are physically tied to the code wheels. They share the same current position math. In the editor, we place all the bridges completely flat for the puzzle, and then we store that Y position, that location's Y height. The flat state represents our solve 0, as we're wanting them to flatten the bridge to walk across it. So for every number above 0 in the current position variable, we raise the bridge's height by 5 units at startup, or whenever you're turning the wheel. So if our code is pyro, meaning hydro starts at 1, the bridge will spawn 5 units in the air, or plus 5 to the Y location. The player sees a floating bridge they can't walk on, and then they spin the wheel from hydro to pyro, which subtracts 1 from the math, which lowers the bridge 5 units back to flat. It doesn't matter what the secret code is really in this case, because the player solves it visually by just rotating the wheels until the bridges are flat enough to walk across. All right, let's get started on the puzzle wheel itself. Let's go to the prefab library up here, and let's search for wheel, and let's find a good base model. Yeah, this one is perfect. All right, let's add it to the scene. Now we need to add the code symbols. We'll use decorations. So if you click the wheel and go to decoration editor here, we can attach assets to our dynamic prefab. We're going to need 4, so let's go ahead and add that. And if we click here, and you might have to expand model here to click this. I already know the elemental badges exist, so we'll just search for that. We'll go, I need an electro one. We'll need a hydro one, and I'm clicking back in this interface here to get this UI back. And we'll need a geo one, and we'll need a pyro one. Okay, since we know what the angle they're gonna be at, we need to first rotate them all to 90 degrees on the x-axis, so they're standing up since they're laying flat. All right, so we know we want them to kind of be around these little edges here, so let's figure out the Y. You can go down here if you're in the rotation mode, switch mode all in one, and let's get a good kind of Y height where they're at ground level with this. I think 50 is good. It's a good flat number. So we'll set all these to, I'm going to Control A, Control C, copy this, and I'm going to just paste it in the location of all of these just to be fast. And if you remember our design map, the electro is opposite of hydro and pyro is opposite geo. So let's map these out. Sorry if you ever hear my dog barking in the background. It's storming really bad right now. Also, I remembered this. If you want to flip this upside down, you can just flip this 180 and do any of the rotations you might want to do for these symbols, because some of them are a little scuffed. Okay, and you'll just have to follow me here. So let's set, let's see, hydro should be here. So that should be like, yeah, 0.50. And since electro is opposite hydro, we'll set that. Actually, hydro should be on the opposite side, sorry. So it'd be that, and we'll set electro to 0.50. And then for geo and pyro, they'll be facing the opposite way, so we'll have to rotate 90 on the y-axis for both of them respectively, and it'd be 0.50 and 50 on the x location. So for geo it'd be, I think, 0.50 right there, and then for pyro it'd be negative 0.50 on the x. Yep, that looks perfect. All right, and as you can see, we have the hydro, or in this base prefab form, 0, 1, 2, and 3. All right, since we'll be stacking these wheels, they need to know their place in the world. So let's select the full wheel now. Let's go to create custom variables, and let's create 3 integer variables. We can just click integer and hit this 3 times. We'll name one wheel ID. I think I might have accidentally wheel ID. What? There we go. And we'll name one puzzle ID, and the other one, this is the most important one, current pos, or current position. So the wheel ID, this tracks the wheel's position in the code sequence. So like 0, 1, 2, 3 as it rises up in the wheel stack. Puzzle ID, this groups wheels together. So we can have multiple separate puzzles in one level. And current position, set this to 0 for now, since we start at 0 at Hydro as a base setup for a wheel. And we can change it later when placing them in the world to the element that we want the code to be at for that wheel. And this tracks our current modulo math position as explained before. All right, and up next, we need to make it spin either direction. So let's back out the variable, and let's go down to add common component. Set a both basic motion device, hit advanced editing, and we will hit plus twice. And we're gonna name one backward and the other one forward. And you do that by clicking these little dots here, and then clicking rename. And for backwards, you might not be able to see this Y here. It can be really scuffed sometimes. Oh, sorry, we need to change these to universal or uniform rotational motion because we want them to spin. And you'll see the Y gets kind of scuffed. Let's set this one as well before you forget. And we'll set the, you won't be able to see it probably, but you'll click it, press backspace, and type -90, hit enter. And for this one, type in 90 and hit enter. And then we can preview this. And it should spin. And down here, give both velocities 90. And there you go. And they spin perfectly. All right, we will enable those in the nodes later. So now let's go and add a tab. You can think of a tab like the things in whenever you approach an NPC in Genshin, the little UI that pops up that you can press F or whatever to interact with, and it starts a conversation like how you talk to Catherine. And so in this, let's just put a placeholder called numWheel, and in the future we'll do this for like first wheel, second wheel, etc. And let's click this little icon, change it to a hand. And for the trigger option area, this is like the box that whenever you walk into, so like whenever you get close enough to Catherine, it appears. And we'll make this just a rectangle, so we'll set the center Y to 0.2, and set this to 2, 2, and 10, because you want it to be high enough, because for the bridge gap puzzle, the wheel's going to stack pretty high. You could make it wider too if you wanted. All right, that's the physical setup done. We have the badges, the variables, the motion, and the UI. So let's connect the UI to the logic. So let's go to the node graph editor and create a new entity graph, and let's call it puzzle wheel. Right click, create node graph. Right click, rename puzzle wheel. All right, let's go and open up the graph by double clicking it. And already we're going to create a signal. So let's add a service signal and select wheel. This is what will be called whenever you use the tabs to pick one of the wheels, so the game knows which one you're interacting with. Let's give it an entity parameter, and we'll name it selector. And we'll hit apply changes. And back in the graph, we'll add a when tab is selected node. And this basically is whenever a tab on this entity is clicked, this event fires. And we will feed that into a, sorry, it's not, it would be a, send signal. And then we'll connect that to that, turn it to a select wheel signal by clicking the magnifying glass, and feed the selector entity into the selector pin. And we'll send this signal to the puzzle manager. Let's save that. Make sure you save that graph, and let's head back to the wheels prefab editor, and let's back out from the tab, and let's go over here to this node graphs and set the puzzle wheel. And now whenever a player clicks a tab, it will fire a signal to our puzzle manager, which will catch it. And let's save this prefab as puzzle wheel, and so we can stamp it all over our level. All right, now let's add the UI for the players to spin the wheels forward or backwards to confirm it. And let's go to the top left here and go to, scroll down a little bit. Your interface will look a little bit different than mine because I have some extra stuff because of a higher creator level. And hit manage UI control groups. And once you're here, go over to the UI control groups library up here and hit add UI control template. And let's add 3 interactive buttons. So do this 3 different times. All right, let's quickly align these up. These here, one here, and this run down here. And let's make each one of these, let's set the wheel, the key that we pressed to use this skill. So where is Q? We have Q for this. We'll give E for checking the puzzle. He's probably down here too, sorry. And then probably R for turning the other direction. And let's also change these to from type interactive event to type button skill. Type button skill and type button skill. All right, let's assign these attacks an actual skill in our class. So for Q, we will assign it slot 3, and for E, which will be the confirm, we'll give it slot 1, and for R, which will be the spin in the other direction, we'll use slot 2. And let's now create a combination, which is just linking all these together. So shift click each one, right click, click create combination, and hit save as template, and go wheel interaction, and hit confirm, and then go top left here, interface layout, go to the bottom, add UI control, and go custom template, and add it in, and there you go. Hit save changes and confirm. Also make sure to toggle visibility off, because we will turn these on with nodes whenever you actually select a wheel in game. Now we need to add buttons for the player to actually spin the wheel to confirm, and also to confirm their code. So let's go to the tab up here, and let's go down to the skill tab over here. We'll hit new skill, and we'll name this one puzzle confirm. We'll name this one spin forward, and we'll name this one spin backward. And let's turn them all into instant skills. So we'll just fire off one graph the second you press the key. And let's add a 1 second cooldown to each spin one, so that the wheel has time to finish spinning before you spin it again. Let's add a 2 second confirmation to the puzzle confirm. And let's save these. And let's go to the player class. And let's, under custom button skills here, click this drop down and click 3. And then let's do puzzle confirm here, forward here, and backwards here. All right. So an important clarification is the difference in client and server logic. So character skills run on the client side, and our puzzle manager runs on the server side. So we need to connect them with those buttons. So we're going to have those buttons send signals to the server side via the character skills. So let's create 3 client graphs here. You have to go to Window, Client Node Graph, Resource Explorer, and then under character skill, create 3 tabs. We'll name one check puzzle status, spin wheel forward, and whoops, sorry, and spin wheel backwards. Okay, and let's go into one of these, and let's create these signals. They're going to be sent to the server side. So we'll just need one for spinning forward and backwards, because we'll just send a different delta, like 1 or -1, which will subtract or add to our modulo to spin the wheel. And let's create a signal called check puzzle, and that will just be used to verify the code. So whenever you press the check puzzle button, it will just tell the puzzle manager to see if the wheels are all set correctly. And we'll have one called spin wheel, and in that one we'll have an integer, like I said, called delta, and that'll be a 1 or a -1. And make sure you always hit apply changes. Now let's wire those to fire our messages to the server side. So on spin wheel backwards, we'll get a send signal node, and we will plug it into here. And for spin wheel backwards, we get spin wheel, and we'll set the delta to 1. I'm just going to copy that. And on spin wheel forward, go here, we'll paste it, we'll connect it, and we'll set this to -1. And make sure every time you do these, you're saving. And then go to check puzzle status and add the, just paste the signal here and change this to check puzzle and plug that in. And now we're about to add these graphs to our skills. So whenever a player presses the button assigned to that skill, it'll fire these graphs off to the server side to do whatever we ask. Let's quickly go back to the skills we created earlier and go click the one you want. So puzzle, confirm, animation editor. And right here on this plus sign, click this and hit check puzzle status and give each, save on each one, and give each one their respective graph. So for spin forwards animation editor, we give it spin wheel forward, and then we save. And for backwards, we do the same. And then we save. And that's it. Our character has buttons. Those buttons trigger client graphs, and those client graphs send signals across the bridge to our server's puzzle manager. And next we'll build the final puzzle checking logic. All right, we'll store our manager on the stage entity since it is a neutral script that manages multiple puzzles at once. Let's quickly create the puzzle manager node graph on the server entity side. Puzzle manager. Go ahead and open it. All right, let's go ahead and add that node graph to the stage entity. Puzzle manager. And let's go to the stage entity's variables, and we will add an entity variable called selected wheel. And this will be where we assign that entity that is sent through the signal when we select the tab on the wheel. All right, whenever our player selects a wheel, we need to save that wheel and show our UI. So let's add a monitor signal, so we can receive that signal we set up earlier for whenever a wheel is selected. And let's have it set the custom variable of the selected wheel that we just set up on the stage entity. Let's get self, because this graph will be on the stage entity, and let's name it selected wheel, and let's feed it the selector, which should be an entity. Yes. And now let's, to turn the UI on, we'll do get player entity to which the character belongs. We'll plug that into a set UI control group status. And so we'll plug that into target player. And we will plug the selector into character entity. So we're taking our character entity from the selector and converting it to a player entity to feed into here. And make sure you connect these. And in here, we should have in here our wheel interaction right here. And let's set it to on. And let's save. Now, if we quickly place one of these wheels on our stage, you can see the tab when you get close. If you press F, you can see our buttons pop up down there. And that is perfect. Let's continue. Now for a cool trick to keep our graphs clean, composite nodes. Think of them like a reusable function. The Milliaster does have a Modulo nodule, but it can output negative numbers, which breaks our puzzle. So we're going to create a custom one. So right click, get a custom variable node, and right click it and hit generate composite node. I see it creates this little white box. Double click that to open it. And up here under create composite node, double click that. And let's name it compact modulo. So inside here, we can expose our input pins or the output pins to the outside node graph. So for example, if we right click target entity here and hit set as composite node pin, it exposes them to the outside because we'll have this new node we can use. And so let's do the same for variable name as well. And so you got to understand the math to fix negative modulo. So we're going to add our modifier +1 or 1 to the current value. and then modulo for it with the modulo node to force it positive. We'll add 4 again, and then we'll modulo for it one last time to get it back within the right range. You don't have to understand it, just know that that's how it works. So let's add an addition node and a modulo node. Modulo operation, and let's copy. You can select it, Control C, Control V to copy these, and set this up like this. We will wire these together real quick. So let's take the variable value, feed it into the top of addition, and let's take drag and select to select multiple. Take the result of that, feed it into the top of this modulo, feed this modulo into the top of addition, and feed this addition into the top of this modulo. And we'll put 4 down here because we're modulo 4. And this will be a composite node pin because this is the delta that we are shifting the modulo by. It will always be 1 or -1, but just in case you ever expand the system. And then we're going to get a set custom variable. And we are going to, since we are wanting to set the same variable that we're getting, we're going to add these to the graph as well. You see up here it's getting busy. Don't worry, we're going to fix that in just a second. Also, the modulo operation will go into the variable value here. Okay, so now let me show you something neat. Whenever you have pins of the same type, you can actually merge them. So if we want to get and set the same variable, we can just click up here, right click, merge pins, and click the other target entity pin. And now hit that. And now you'll see there's just the number 1 pin, and any data fed into this pin on the outside will go here, and it will go here. And let's do the same for the variable names. All right, that has helped a lot. If we hit 3, we can give this a custom name. We'll name it modifier. And now for the connecting pins, we will set this as a pin and this is a pin. And that should be it. So basically, whenever you connect into this, you'll feed the entity that you want to change the modulo value of, and you'll give it the current pos variable name, usually. The modifier, like 1 or -1, and the modifier will go into here, and it will do all the modulo math on that variable, and then it will set it again here. And we hit save, and it's that easy. All right, let's go back to our puzzle manager, and let us see our new compact module. And if you want to get this, you can also find it at the bottom here under composite node, or you can just search for the name. And now let's get our wheel spin signal that is being fired from the key, if you remember. And we will feed this into here, and we'll plug the, we'll get the signal for spinning with the wheel. The delta will go into the modifier. So remember, 1 or -1. And for this, our variable, whether on the bridge or on the player, will always be current pos. Let's not forget to also get our the entity we want to set the current position of, which is the wheel. And to do that, since we are on the stage entity right now, we will get the stage entity's selected wheel variable. So self, feed that under target entity, selected wheel, and this variable will go into target entity. And now whenever select wheel sets the variable for whatever wheel we chose with tab, it will now update this whenever the wheel is set to spin. All right, now let's add the actual spinning part. So we'll take a multiple branch, which is basically like a switch statement, if you know what that is, and we'll plug this in so it happens after modulo, and we will take the delta and feed it in as the control expression. So it's basically acting on whatever this value is. And we will add 2 values here. So 1 for 1 and 1 for -1. And now, depending on if our delta is 1 or -1, we will go forward or backwards. And to do that, we will need the activate basic motion device node. There it is. And I'll just copy paste this because we'll need 2 of them. And we're gonna want to do this on the selected wheel. So grab this entity over here. We're gonna be using that selected wheel entity a lot. And we'll remember the motion device we named earlier. This is where it matters. And now we will plug. You have to have default plugged into at least one of these. So we'll plug default into forward, 1 into forward, and -1 into backwards, and hit save. And now if we go in game, the wheel will spin forward and backwards. I'm sorry, I misspoke earlier. You don't connect the selector to the selected wheel. The selector is just to pass our player on for the UI stuff and some other things later, potentially. The signal source entity, which is the thing the tab is attached to, is what we want to attach to the selected wheel. Sorry. And now you can see if we go up here and select the wheel and press Q or R, it will spin either way. Perfect. If you haven't already, please drop a puzzle wheel that we had saved over here into the actual world, and let's customize it for our intro gate. So first, we need to group these wheels together in the property panel. In order to do that, let's go down to unit tags down here, add unit tags, open unit tag management tool, and create a new unit tag. And let's just name it gate puzzle. We can copy its index ID and make sure you hit the check mark to assign it. And now go to the custom variables and set the puzzle ID to the tag ID we just copied and make sure it is correct. So the reason why we do this is because later our puzzle manager can instantly find every wheel belonging to this specific gate just by searching this tag ID with a very nice node. So it's really helpful to keep all of our puzzle pieces together. All right, before we stack them, let's set our code. So our code's going to be hydro, pyro, geo, hydro. And remember, we want all our wheels to reach 0 when solved. And here's the easiest rule of thumb for setting your current POS code. Just count how many counterclockwise turns it takes to reach your target badge. So for pyro, it's 1 counterclockwise turn from hydro. And for electro, it's 2 counterclockwise turns from hydro, etc. So hydro is a starting point, so it takes 0 turns. So current position 0 makes sense for hydro for this one. Pyro is 1, etc. And so our sequence starting from the bottom to the top would be 0, 1, 3, 0. Now for this bottom wheel, we'll just leave the wheel ID in the current position as 0 because that is the way the bottom wheel should be in this instance. And then we will just Alt, click and drag up here 4 times. We'll hold Alt and click and drag this arrow. If you don't have the arrow, you can change to move/all-in-one. And once you have all 4, we can start editing them. Now let's go up the stack and start editing. So for the second wheel, we will set its variable for its wheel ID to 1, its current position to 1, which is pyro. And we'll go into its tab and call it second wheel. And if you're not dumb like me, you'll go back and edit this because I forgot. First wheel. And then for the third wheel, we will go here and set its index to 2 and give it the current position of 3 because this is the geo one. And let's go give it the name third wheel. Same. And then go here and let's give this one the third wheel ID, and its current position should say 0 actually because it's hydro. And let's tag this one as fourth wheel. And just like that, our gate puzzle is physically built and mathematically configured. All right, let's quickly set up our actual door that's going to block the players. Please make sure to keep saving your level. And let's search for stone fence gate. And we'll go through. Oh, all right, that's perfect. Raise it up here. We would have to scale this probably to fit the cave whenever we build the actual map in the third part, but this works for now. Let's add a basic motion device so it can move. It will be a uniform linear motion, so that's perfect. We'll name it the same as we did the other ones, so we can address it in the node. We'll name it raise gate, and we'll set the duration to 3 seconds and velocity vector y to 5. And this all seems good to me, and it's all turned off. And if we preview it, it works great. And we will turn this on with nodes in a minute. All right, let's create a new graph called server entity graph called gate puzzle. And inside it, let's create a new signal called raise gate. Apply. And in the graph, we'll just monitor for that signal. And we'll wire it to activate the motion device. Plug the event source entity as the target entity and name it what we named the motion device, which I believe was raise gate. And now let's go attach this to our gate. All right, back here. Let's go add the node graph for gate puzzle. And now when the puzzle manager sees all zeros, it can send the signal to raise the gate, and the gate will rise, and the player can escape onto the pit building and into the lantern area. So now let's build the final code checking logic in the puzzle manager to make all this work. All right, let's build the final check inside of our puzzle manager. We're going to use a dead man switch loop. We will assume the player is right when we check every wheel, but if even one wheel is wrong, we flip the switch to false or a local variable to false. And at the end of the loop, we will check if that variable has ever changed to false. Okay, so let's get our check puzzle monitor, or signal, sorry. And we need to get our selected wheel. We can actually just copy this from here. Get our selected wheel, and we need to get its puzzle ID. Make sure this is set to integer. Plug that target entity into that. Actually, this should probably go up here. Let's get this away from everything else so it doesn't crowd it. Okay. And then let's get the entity list for the unit tag. And let's feed the puzzle ID into here because this is the unit tag. And this will get a list of all the wheels grouped in the puzzle. And we will get a list iteration loop. And we will plug that into that. So whenever we get our check puzzle signal, we'll start running this loop. And we'll plug our entity list down here. And that will make it loop over all the wheels. All right, now we want to check if the wheel current position equals 0. And so since this basically, since this iteration value here basically equals our wheel entity, we'll get a get custom variable. And we'll plug it into the entity. And we'll do current pos, set to integer. And we'll get an equal. Plug it in the top node, 0. Get a double branch and plug the loop body into that. And then plug the result into that. So basically what's happening here is on every loop, it's checking the wheel's current position. And this creates a Boolean, so true or false. So if this equals 0, for every wheel, it'll check if it does. And then we will act on that. So for this, let's set up a local variable to track the deadman switch. They're a little weird and janky to set up. So we need these two nodes. And then basically you plug the local variables together like this. And then we'll set the initial value to a Boolean. And we will set that Boolean to yes. Turn this also to a Boolean, and we want to set it to no, because This is the dead man switch. So, so basically anytime a wheel's current position does not equal 0, we're going to feed it into this, and it will set the local variable to no. And that means that we can now track. We don't have to go over each code sequence. If there's ever a wheel that is out of alignment, then we will know thanks to this. All right, and now we can handle when the loop ends. Because the loop body, this basically, the loop body executes for every single item in the list. Or you can break it if you wish. You have to feed the break node back into here. Let's move this up here. But for now, let's copy this branch and paste it. And this will check at the end of the loop whether or not the variable was ever set to no. So we get the local variable value from the pin here and feed it into this. And even though it's not going to look great, I'm going to pull it all the way back here just to save space. And if it's still true, then they solve the puzzle and we can send the signal. And if it's not true, then we can just wait. Let's add some timed effects to show that they did it right or wrong. Sorry, to yes. And I already know what one I like because I used it in a previous project. It's called green surrounding floor. It shows like a big green flash. And we'll set the target to the player's GI, capital GI underscore capital R root capital N node. And we will set this set all the offsets to 0. Set the zoom multiplier to 1. And for the target entity, the signal source entity, which is the player's entity. So we'll plug that in over here. And then to make filling out the rest of the no one out, we'll just copy paste that and we'll plug the no one into here. And this means if the wheels were not filled out correctly. And for that, let's use, see if I remember the code for this. I think it's like 1000, 4004. Yeah. And of course, set the same entity. And now whenever you try to confirm the code with the key, it should flash green or red depending on if you did well or not. All right, and finally, if they did do it correctly, let's turn the UI off since they won't need it anymore. Let's get the UI control group again. Let's plug it into the yes. And UI needs the player entity. So we'll get this node, get player entity to which the character belongs. And we will just get the usual signal source, which is the character. And we will plug that into the target player. And then we will get our wheel interaction control group, which we created before, and we will set it to off. And then one more thing we want to do is we want to get an equals. So basically we want to make sure that, because this is going to be puzzle agnostic, it should work for all puzzles. We're going to want to make sure that this is the gate puzzle before we raise the gate. So we're going to put another branch here, another equal node, and we're just going to make sure if the puzzle tag equals the index of the gate puzzle. So you're going to want to get the puzzle ID here and feed it into the top of the equals node. And you're going to want to put the unit tag index here, which you can copy from the wheel. And we'll feed that into here. So if it ever equals if the puzzle ID ever equals the gate puzzle ID, then we will run this. And this is when we run the signal to raise the gate. And that is perfect. Save it and test it. Actually, it's not perfect because you actually have to select raise gate and then save. There is one change that I would make in Puzzle Manager. If you go to where the signal wheel is, in between compact modulo, I would create 2 set character skill cooldown nodes. Hook them together. Disconnect. You can see right click. Disconnect the link here. And connect it here. So these form a chain. So basically we're going to put the spin left or spin forward and spin backwards skills on cooldown at the same time. This way you can't spin forward while you're also spinning backwards, because then it messes up the rotation angles and it makes the wheel go out of whack. This is just a nice way to guarantee that they're both on cooldown. So just drag the signal source entity into here. And I think it should be skill slot 2 and 3. And put 1, 1. And that's all you need. If you hit save and when you go in game, it should work perfectly. Now you'll see if we try to spin, it can't really get out of whack. And that's a lot better. All right, perfect. And now if we try to set the code, if we go to the second wheel, rotate it to Pyro, and the third wheel, rotate it to Geo and press E to check the code, it should pop green and the gate will go up. And we have now created the first puzzle with the wheel, and we can now set up everything else that is to come. This is a very amazingly modular system. You can pretty much tap this into anything, which is the whole purpose of this being its own separate video. And yeah, I hope you find that very cool. Another thing to note is that I will, for every part of the video, I will include a project file checkpoint in the description, so you can compare your work if you got stuck somewhere or something went wrong. And I'm going to dump the project exactly how it is right now, since we've reached a major milestone of having the first part finished. And this modular groundwork will make adding the future puzzles, like the bridge portion, which just requires a little bit of updating to the code. And next up, we will work on the bridge and lantern mechanics.